My mom's boyfriend is a photographer, right? And at Korea school, we do what's called a capstone, which is a research throughout the entire year that is every sixth grader does. Mine was on black holes and wormholes. Uh, but My mom's boyfriend mic'd me up. Everything. I was in a suit. It was hilarious. I loved it, but I have no content, so I'm just gonna post that because I think that'd be fun to post. But here, I'll show you. When I wanted to learn about black holes, I watched Interstellar, and that really inspired me to learn about more of time dilation, the event horizon, and much other, such as the light ring around it. The light ring is one of the most important things of a black hole. It's what makes a black hole visible to the human eye. If the black hole didn't have the light ring around it, we wouldn't be able to see it, because the black hole is purely black. It's purely theoretical as well, until we saw one in 2012. This is a picture of M87 from the MESR-7 galaxy. It's a black hole taken in 2012, released in 2019 by NASA. A black hole is a region of space where a matter is so crushed into a singular point where its gravity and mass is the same thing, just in a smaller and singular point. For example, if you took Earth and crushed it down into a black hole, it would be the size of about an apple. Now, if you crushed the sun into a black hole, it'd be the size of 2 miles long, which is very surprising to me since the amount of mass. So my question was, how much suns did Sagittarius A eat? Because Sagittarius A is the biggest black hole known to man, with a mass of 4 million solar masses. One solar mass is equivalent to one entire solar system combusted into a singular point. The close second being M87 with a mass of 3.7 million solar masses. Now the best way to create this crunched up area into a singular point would be the Schwarzschild radius formula. The Schwarzschild radius is a formula created by Carl Schwarzschild in 1916. Later that year, he died due to a illness he contained in World War I. But the Schwarzschild radius is a very complicated thing, but it's about the event horizon. Rs over here would equal the event horizon of a black hole. G would equal the gravitational constant. M would equal the mass of the object, and C would equal the speed of light, 299,792,458 meters per second. Now, spaghettification is a process where when you get sucked into a black hole, you'd start slowly seeing your legs get turned into spaghetti-like lines, and due to the immense gravity of a black hole. Now, the gravitational formula for anything really is this here. It's this F, the capital F here, would equal the entire formula itself. But as I said before, G would equal the gravitational constant, M would equal the mass of the object, and this little m here would equal the distance from the center of the object. R here would equal the distance from the object itself, and then if you put all that together, I did the same thing for Earth, which would be 0 and 6,647 trillionths times 59,722 tentillion and 12 thousandths, divided by 40,058,589,641, which would equal 97,801,431 and 48,020,673 millionths, which is this here. What I just said was the gravitational forces from there for Earth, which took me a while to get, but I used a calculator for most of it because I couldn't do it with my head. But time dilation is a big thing when it comes to black holes, because a time dilation is where the more gravity you have, the slower your time moves in your perspective, or in the other person's perspective. So the formula for it would be here. I wrote it up here. So it's delta t apostrophe, which would equal delta t divided by the square root of 1 minus 2gm divided by rc squared. G would equal the gravitational constant, M would equal the distance of the object, R would equal the distance from the distance from the center of the the distance from the object, and C would equal light speed. But delta delta is the triangle here, and it is a Roman numeral. Invented in like something BC. I don't know what it was. I forgot. But delta t would equal delta t apostrophe would equal the entire formula mixed together. Delta t would equal a standard hour, meaning an hour on Earth. So if you took an hour on Earth and then divided it by the mass of the object, the gravitational constant, and then divided that by divided by r, the distance from the object, and then the light speed, you'd get for Jupiter. I did this, and it was almost 3 times less time that it's experiencing than us. So if we spent 3 years on Earth, it would spend roughly around a year on Jupiter, causing its time to move slower, as well as us seeing it move slower. So if you throw in something into a black hole, you'd slowly see it get sucked into darkness, as well as seeing it move in what seems like slow motion, until it gets to the event horizon, which is around. If my model here is like be around here, but it slowly gets sucked into darkness and then suddenly almost freeze in time. Now, a wormhole is different than a black hole here. A wormhole is purely theoretical. This is a theoretical description, but a wormhole is a gateway through a dimension, teleporting you into a distant point in your universe. Such as if you take a piece of paper, for example, here. If you take a piece of paper and you bend it, let's pretend it's 2-dimensional, but if you bend it and then poke a hole through it, you'd just make a wormhole through the next dimension. Now, go back to Carl Schwarzschild here. In 1913, the idea of a black hole was introduced. And the singularities that Albert Einstein and Nathan Rosen were trying to avoid ended up being the event horizon of a black hole. They were trying to figure out what a black hole was, what's causing their entire thing to go into pieces. Then they figured out the Schwarzschild radius formula, which Carl Schwarzschild created. But they figured out the idea of a black hole. In 1935, Albert Einstein released papers for failed experiments to unify electromagnesium, but he went back in time, and not really back in time, but he went back in history and then got Carl Schwarzschild's formula, and that's how he figured out how to make a black hole, or not make a black hole, but what a black hole is. Now, a dimension is a thing that defines what you can see from your dimensions, such as us. We're in the 3rd dimension, which has width, length, and depth. Now, the 1st dimension only has width, meaning it's just a line. Now, if you wanted to trap a 1st-dimensional creature, you'd draw 2 dots around it, causing it to not go left or right, so it's basically trapped. Now, a 2nd-dimensional creature would just go really upward and escape the cube, but a 1st-dimensional creature would not know what it's doing. Now, if you wanted to trap a 2nd-dimensional creature, you draw a box around it, but we just step over it. Now, if you wanted to trap a 3rd-dimensional creature, you just put a cube around it. But a 4th-dimensional creature has time as one of its dimensions. So it just traveled to a time it was never in the cube in the first place. Meaning it could travel years back, milliseconds back, seconds back, anywhere. But if it was never in the box ever, then it'd basically be out of the cube, causing us to be confused on where it came from. Because I'm not sure if we can see it when it gets teleported to a different timeline, but I'm assuming we can, because it's still a physical object. Now, if a wormhole gets closed in the middle of nowhere, it causes a black hole to form on both sides because of the immense unbending of the paper itself, causing a black hole to form on both sides. Now, if something was inside of this in the first place, then it'd get teleported to a distant place. If something was inside the wormhole, going through it while the wormhole gets unbent, then it would be in the middle of the distant points in the wormhole, such as if you had one here and here, and then you bend them and then poke a hole through them, and it's traveling right around in the middle here. And you unbend it, it arrives around here in its dimension, because it can't go into a higher dimension unless a higher dimensional creature picks it up and puts it into its dimension. And I think that's my presentation on black holes and wormholes. Thank you. Any questions?
Why was that scientist your favorite scientist?
Which one? Carl Schwarzschild?
Yes.
He was a famous German-born physicist that died in 1916. I forgot what date he was born, but he was it was a very genius scientist inventing the the Schwarzschild solution and the Schwarzschild radius. Schwarzschild solution having singularities at both 0 and the Schwarzschild radius. Yep.
Do you think it would, and this is a stupid question, but do you think it would hurt going into a black hole, or would you just be straight up dead?
It really depends on how quick it would be. It would hurt either way, but the bigger the black hole is, the more gravity it has, so it'd be just like that. Either be over in seconds or over in hours. Yep.
What was your favorite part making your capstone?
Learning about time dilation was a really interesting part to me, especially the formulas about them, such as Schwarzschild radius, time dilation, and gravitational force. Yes, Heather?
How do you make a Schwarzschild radius
I'm not sure you can.
question?
I'm not sure you can make a Schwarzschild radius question.
Like a Schwarzschild formula question sometimes.
You'd first have to get a black hole, but if you use the Schwarzschild radius formula, you'd find where it is in that black hole. Yep.
So the Schwarzschild radius formula measures the event horizon?
Yes.
Correct. Can you tell me what the event horizon is exactly?
The event horizon is a point in a black hole where time seems to stop completely. It was a very interesting thing for years upon scientists and astronomists, I think. It was a very complex thing. Astronomers didn't know what were happening with their thing. Even Albert Einstein was confused. No idea what was happening with it. There was just a point in where time just stopped. Until they learned the Schwarzschild radius formula by Carl Schwarzschild, which fixed everything in a black hole. There's?
Would you die if you went through a wormhole?
No. Wormhole and a black hole is different. Wormhole is a gateway, like a portal through a dimension. It just take a little while. Really?
Has anyone ever tried to go through a wormhole?
It's purely theoretical, so no one's ever seen one. Yeah, right.
What inspired you to make this topic, or to choose it?
After watching Interstellar, I learned a lot more about time dilation and dimensions, and more wormholes and black holes. So I figured that would be a really good topic to do on my capstone.
I'm sorry, but if no one has ever seen a wormhole, how do they know if they even exist?
It's purely theoretical, so we don't know if they exist. But it's the best way because if we can do it, then the fourth dimension can probably do it with us. Taylor?
If fourth dimensional creatures can travel through time, do they so let's say a fourth dimensional creature was 15 and then they travel through time until they would normally be 300. Would they change the age or would they still be?
They'd still be the same age. It's like time travel in movies like Back to the Future. Yep.
I have a question about time dilation.
Mm-hmm.
Say when you're getting faster and going toward something with high gravity, time
Yeah.
will slow down.
Yeah.
So if you're heading toward a black hole which has a lot of mass, a lot of gravity, do you notice that time is slowing down for yourself?
For yourself, no.
It just seems normal?
It seems normal for you, but for others, you see them move in super speed, basically. Because if, let's say you put a civilization here, and let's pretend this is Sagittarius A. There's a civilization here that's not affected by the gravity of the black hole, but you are. So you slowly get sucked into it while seeing this civilization evolve quickly and quickly and quickly until it seems like it's basically in the future while you're only here on the event horizon of a black hole.
So time is relative.
Time is, yes. And that's it.
Okay.